I'm back here to complete our discussion on bacteria. So let's look now at a kind of a unique kingdom of bacteria. So what you know up to this point, we know about the kingdom Eubacteria, right? Eubacteria. It has peptidoglycan, it's ubiquitous. This type of bacteria involves beneficial forms, pathogenic forms, all that stuff. Well, now we're going to progress sort of backwards to the Archaebacteria. Right? When we hear the word archae, that refers to archaic, ancient, very old. And this is a very unique type of bacteria. I include here a picture of a motorcycle guy doing a stunt. And I don't know if you're familiar like with the Olympics, where you have these top level athletes competing in running and gymnastics and all that kind of stuff. Well, here we have a different type of Olympics. I don't know if you're familiar with the X Games, extreme games. Well, the extreme games remind me of the Archaebacteria. It's just not normal sporting events. It's extreme sporting events. And the Archaebacteria are known for their extreme types of environments in which they live, their extreme habitats. So they are bacteria. They are prokaryotic, right? So that's a similarity. But what they are not is they're not protected by peptidoglycan cell walls. So peptidoglycan is very distinctive then for Eubacteria, not found in the Archaebacteria. So if you remember peptidoglycan, protein and carbohydrates, right? That is the protective macromolecule cell wall that the bacteria need to survive, the Eubacteria need to survive. So what's going to happen now if you're a bacteria, an Archaebacteria with no peptidoglycan? You say, well, man, now I'm vulnerable, right? So we cannot conduct the gram-positive test. We cannot conduct the gram-negative test with these bacteria because they have no peptidoglycan, right? So they're basically bare out in the open. Their membrane is quite distinctive as well. If you remember from 1306, our plasma membrane would look something like maybe this, where we have a hydrophilic, hydrophobic fatty acid tails, not connected, another fatty acid chain from another phospholipid, and then again, a hydrophobic, my little arrow, hydrophobic, hydrophilic here. So this is what a normal membrane is supposed to look like. Well, if you look at the membranes of the Archaebacteria, they're modified, right? It depends on the types, but some of them look like this. So they're literally connected. The phosphate regions, the hydrophilic regions are literally connected. So you don't technically have a bilayer. It's just a unilayer membrane. Some of the fatty acids are connected in some of the membranes. So there's different modifications for the different types of Archaebacteria. But the moral of the story, the membranes are different. The cell wall is lacking, the membranes are different. And if I pose the question, well, why do you think this is the case, right? Well, it's gonna go back to the idea of the extreme habitats. I don't know if any of you like the heat wave we're having right now. It's hot, it's been, past couple of days has been quite warm. I don't know, I think it got up to 105, maybe somebody said 108. I can imagine places like Phoenix, Arizona, much hotter, maybe in the Middle East. I don't know, maybe some of you were in the military, you went over to Middle East. I've heard that it gets very hot up there. Well, if you can imagine, let's say the upper limits for human tolerance. So let's say maybe 115, 120, 130, we're starting to get to an upper level temperature where it's not conducive for life, for a human. It's too hot for us. Well, let's say 130, 140, too hot for us, we would die. Archaebacteria, these heat-loving bacteria, would also die. Not because it's too hot for them, it's too cold for them at 130 degrees. So they like extreme heat. They like extreme acidity. They like extreme alkalinity. So if we go back to the idea of the resource partitioning, right? Trying to minimize competition. If me or you could survive in an environment where nothing else could survive, that would enable us to reduce competition. We would sort of be in an environment where there's no predators. We would have all the resources to ourselves. And that's kind of what has happened with these Archaebacteria. So they've kind of evolved and continue to survive in these very extreme habitats where nothing else can mess with them, basically. There's no predators, there's no competition. So it's a neat strategy for these extreme Archaebacterians. So again, 3 categories of Archaebacterians. We talk about the thermophiles, the heat lovers. These types of bacteria love heat. They love really hot temperatures. So they do well in, let's say, these areas where you have magma, you have these hot springs. These environments would be very conducive to these, the thermophiles, heat lovers. Halophiles, halo means it refers to alkalinity, to salt. So I don't know if you're familiar with this picture here. This is a picture, if you're here in El Paso, if you drive out to Carlsbad, take, the 62-180, drive Montana, you keep going, and you go into the Guadalupe Mountain National Park. Right before you get there, just west of the national park, you have these big salt flats where all the rain from the mountains drains, kind of collects here, and then the water evaporates, all the salts and the minerals stay behind. Well, in these types of environments, it's too alkaline, too salty for many things to survive. There's a few crazy plants that can survive, and also we have these alkaline-loving bacteria, these Archaebacteria we call halophiles. On the opposite spectrum, we see a big fat cow here, right? So if you know anything about cows, if you've driven between here and Las Cruces, you smell the cow smell, right? Kind of stinky, a lot of methane that they produce. Well, actually, yes, the cow is releasing methane, but it's not the cow actually that's producing the methane. It's the bacteria in the multiple stomachs, these Archaebacteria that live in that acidic environment. So the methanogens are the heat-loving forms of, the methanogens are the acid-loving forms of the Archaebacteria. So in the stomachs of different plant-eating animals, we tend to find these methanogens. So it is their fault that the cows are so stinky, basically. And so they're releasing all the methane, living in alkaline environments. We have our thermophile, the heat lovers, and our halophiles there in the salt situation. So evolutionarily speaking, right, it is hypothesized that we have, if we go back in the history of the Earth, in the early development of the Earth, there's this idea that the atmosphere was different, the conditions were different, the amount of oxygen in the atmosphere was different, and it is hypothesized that these Archaebacteria would have been the first forms of life that actually originated. Right? So we think they're the most ancient forms of life, and after this crazy evolutionary sort of radiation happened, then we started to kind of go into more common, more typical environments. So leading to the eubacterians, right? But again, hypothetical, a lot of phylogenetic research that's been done, that's being done on these types of I guess, hypothetical recreation of the past there. So there's a little video here. I don't know if it'll work right here, maybe. No, I cannot play media, sorry. So it's not gonna work from here. I'll see if I can find the video and I'll upload it. It's a really short clip, just kind of documenting a little bit of the Archaebacteria and their hypothetical sort of rise to life there, right? So with that, it should be the last slide. So that finally concludes our discussion on bacteria. So the Archaebacteria, and the eubacteria. So let me go way back here. So with that, that concludes our discussion on that branch, the early branch of life, right? So the Archaebacterians, extreme dwellers, and then the eubacterians. I don't know if you've gotten to protists in lab. Maybe you have already. I'm going to cover those quickly next week. I'll fly through Protista, and then we'll continue into our last remaining categories: fungi, plants, and animals. So with that, again, let me conclude this. So with that, I will basically call it a day and keep an eye out for this video and keep an eye out for communications through your My EPCC. So with that, y'all have a good one. I'll see you next time.